If you're learning about Google Cloud Security, I have the episode for you. I have Marcus and Marian, who work for Spotify, sharing all things Google Cloud Security over three-part series videos. Basically, there are a set of 4 challenges. Session 3, which is this part, they'll help you set up the prerequisite. And part 3, we'll be finishing off with the challenge 3 and 4. So overall, with the part series, you'll be able to get to learn a lot about Google Cloud Security, including GKE, which is the Kubernetes engine from Google Cloud. Marcus and Marian made these three-part series as part of the Advent of Cloud Security by Cloud Security Podcast. So you can also find these videos on advent.cloudsecuritypodcast.tv. But for now, let's enjoy session 3.
Welcome to the next session of the Advent Calendar and our GCP CTF workshop. In the previous session, we had a look together at challenge number 1 and 2, and now we're going to continue with challenge number 3. But before that, let's do a super quick recap of the previous challenges. So in challenge number 1, we found a misconfigured GKE cluster that allowed us as an attacker to access Kubernetes secrets on the cluster. And in those secrets, we found a service account key. And in challenge number 2, we used that service account key to gain access to a storage bucket in the GCP project. This is where we're going to continue with challenge 3. But to make sure that we're all up to date and ready to start, I can do a quick recap of the most important commands for challenge 2. So here I stored my service account key file in my temp directory, and I will use it here with the command gcloud-auth activate service account. And this tells gcloud to use this credential when authenticating against GCP. And I can now use all the permissions that this service account has. By the way, if you want to switch that back to your actual user account, you can run gcloud-auth login and it will switch it back. And you can also run gcloud-auth list if you want to see who you're currently authenticating as. So for now, we're going to stick with the service account key. And we also in challenge 2 found the name of a storage bucket that we can access. And we can do that, for example, with gsutil ls and then the bucket name. Your bucket name will be slightly different because you will have your project ID here in the end. So I can access the bucket, and on the bucket, I find 2 files. The first is a flag for challenge 2, and the second one is a file called terraform tfstate. And this is where we're going to continue with challenge number 3, and we're going to take a closer look at that file. All right. So to access the file, I can either run gsutil cut and then the file URL to read it directly on the storage bucket, or I can download it onto my machine, which is what I'm going to do here by giving it the file URL as source and then wherever I want to store it as destination. So I'm going to download it here, and then let's open it up. We can see a larger JSON file that contains a bunch of information about GCP resources. So here we can do a quick background information on the Terraform state. When you create resources with Terraform, then Terraform needs to store which resources it manages and also what the configuration of these resources is. And it does that in this state file. You also created a state file when you used Terraform to set up all the resources for this workshop. So also in your local directory where you did that, you will have a state file. However, when multiple developers work on the same Terraform code, then they also need to share the same Terraform state to avoid conflicts. And one very easy way to share that state file is to put it on a storage bucket. And then when you configure Terraform, you can tell it that you want to use this shared state file on a storage bucket. So it looks like the admins of our misconfigured GCP project also did that. So for us as an attacker, now that we already compromised the storage bucket, we can gain a lot of information about what other resources are defined in that project, including all of their configuration options and parameters. So for challenge number 3, your goal will be to gain control over the next piece of infrastructure that you can see configured and deployed here with Terraform. And you actually don't need any gcloud, gsutil, or other GCP-specific commands anymore for challenge 3. You can find all the information that you're going to need in the state file. For example, where you can access the next resource, which user is allowed to access it, and you can potentially also find a credential that you're going to need as well. And you might have to base64 decode things again. So here you can pause the video if you want to solve challenge number 3 by yourself. And we are going to continue with the walkthrough of challenge 3 in a minute. Okay, so if you solved challenge 3, then you gained access to a compute instance that is also running in this project and was defined via Terraform. So let's do the steps together now. Here is the definition for the Google Compute instance in the state file, and we can also see all its parameters here. But additionally, in the state file, we can also find a Google Secret Manager secret defined. Google Secret Manager is the secret management solution that GCP offers. And you would first define the secret, which is basically a container for another resource, which is called secret version. And the secret version will then contain the actual secret value. The secret itself has some metadata, so I can see here, for example, that it's called SSH key. And then further down in the state file as the last resource, I can see the Google Secret Manager secret version defined, which is going to contain the credential. So here the secret data will be really interesting for me. And I'm going to copy that and base64 decode it. And it does contain an OpenSSH private key. So to use this key later, I'm going to store it in a file. And I'm also going to set the file permissions to 600 so that my OpenSSH won't complain when I try to use it later. Going to set that. And now to SSH into the compute instance, what I am also going to need is the IP address of the instance. So when I search for IP here in the file, I can actually find two. I can find the net IP here and the network IP down here. The network IP is a 10.IP address, which is only used within the virtual private network within GCP, so I can't reach it from outside. But I can reach the net IP here. So I'm going to copy that. And the last thing that I'm going to need is which user is allowed to SSH into this machine. And I can see that defined here. So in GCP, one way how you can store the public SSH keys of users that are allowed to SSH into the boxes is here in the metadata section. And that is what is done here. So this is the public part of the key, and it's associated with the user Alice. So with all of this information combined, I can now SSH into the box like this. So I will specify the SSH key with the -i parameter, and I will SSH as the user Alice and use this IP address that I found. And it works, and I can gain access to the compute instance. And once I'm on here, I can also find flag number 3 in Alice's home directory. So congrats if you found flag 3 here, and if you compromised this compute instance. So this is the solution for challenge number 3. And before we wrap up here, we can go through the key takeaways again. So one thing is the Terraform state file. If you define secret values with Terraform, like the developers did here, then they will end up in the Terraform state file. So you would either have to treat your state file also as a secret and make sure that only authorized people can access it, or you would have to avoid defining secret values with Terraform. The second thing is that we were just allowed to reach this box, and also port 22 was reachable for us from the internet. And this is because when you spin up a compute instance in GCP in the default configuration, first of all, it will get a public-facing IP address as well as its private IP address. You can, of course, configure it differently, but by default, it will have a public-facing IP address. And additionally, GCP will give you a set of default firewall rules. And one of these rules is allowing connections on port 22, the SSH port, from the internet. So once we found the private key and the rest of the information, there was no other firewall or network configuration that would stop us from SSHing into this box. Okay, that's it for challenge 3. And then for challenge number 4, the last challenge where you can compromise this project completely, I will hand it over to Marcus.
Hello everyone, and welcome back to challenge 4. In the previous challenge, Marian showed you how to get access to the running compute engine we had in this GCP project using the SSH key and the IaC account. Now, once you have established foothold on this compute engine, I'm going to show you in challenge 4 how to expand that foothold and get more access based on the configuration we have for this workshop. So by doing so, let's start to go back into the compute engine and see what type of permissions we have. I'm going to do so by, again, SSH into the compute engine. And here you have me logged into it, confirming which directory we're in. And if we list the files here, you see the flag 3 here from the previous challenge. Now, let's start by seeing what service account this compute engine has attached to it. So here we have information about the service account, and it's the default one, which is good for us because that means we can start to look at the permissions that this default service account have and see what else we can do. Now, a good way to do that is to get some additional information, is to query the GCP metadata server about the service account to see what scopes and permissions we have in place. So here we see some general information that we can use, for example, about the email, identity, scopes, etc. Now, let's start with something simple like listing all the running compute engines in this GCP project. So if we try to do that, we quickly see that we don't have the necessary authentication scopes for this service account to do this. So a common way to list all of the scopes that are available for the service account is to use the following query here, which basically lists this for us. So if we try that, we can see the scopes being listed here. And there's a couple of common ones here, but there's one in particular that is interesting to keep in mind. And this is the dev storage read only. This would allow us to read all the cloud storage buckets in this GCP project using this default service account. Now, with this in mind, we can now try to figure out if there's any cloud storage buckets that we can use to pivot externally into this environment. And in this section here in the repository, we have listed some of the useful commands that you can try to do this. Now, this was the first part of the introduction to this challenge, so I would suggest you try this out on your own, and then I will cover the solution in the next section. Hello and welcome back. We're now going to walk through the solution to challenge 4. As you probably saw down here under the commands and tools we had listed, there was a reference to gsutil that you used in the previous challenge to list the storage buckets in the project. Now, using the permissions we have on the compute engine that we accessed, let's try to use this again to see what we can get. So first, I'm going to SSH back into the compute engine using the SSH key and the IaC account. Now, let us list the storage buckets that we have. And as you can see, we can have access to quite a few of them here. So this one listed as challenge 4, obviously, is maybe the interesting one to start with. So if we go here and we look at the files in this particular bucket, we see there's a file in here that looks to be a Python script. Now, if we then try to access that file and see the contents of it, let's see what we can figure out. So if you came this far, you probably saw that this is a Python script that looks to reference a cloud function in the GCP project. Now, when you create a cloud function in a Google project, Google also creates a storage bucket where the source code is copied. This to allow you to make modifications and do other things. Now in here, you can see that there is a couple of references to the actual content and also the flag itself, but also that if you do a request to the cloud function and you specify the token in the metadata parameter, you get a specific response. So this is a good clue for us to work with. Now, if we also look at the files listed on the compute engine itself, we also see one here, which is a bash script. Now, with this in mind, what we can actually do is to open up this one as well and see what it contains. So this script appears to be querying the same cloud function. And in here, you can see that there's a specification made both to the location and the product ID, but also there's a metadata field here that is email. Now, let's try to invoke that and see what we get. Okay, so we get a response telling us that the compute engine is up and running. And this appears to be a reference to the heartbeat. So basically, you query the function, and it tells you the status of the compute engine itself. Now, if you remember, we also had access to the source code of the cloud function, where there was a specification made for the metadata field, where instead of email, you could have token specified, and that would give you a separate answer. So let's try to use this command right here and make a modification to instead use token instead. Now, here you can see we get a very different response. So in this case, we get a refreshed access token for the default compute engine service account. Now, the interesting thing here is that the same service account is used both for the cloud function and for the compute engine. And if you remember when we looked at the scopes of the compute engine service accounts that we have, there was a limitation to what we were allowed to do based on the scopes. So if we now save this token that we have right here, we can actually see what scopes that are available for the same service account, but that is used for the cloud function instead. So let's export this value here. Now, going back to the project, we had a command in the repository here that allowed us to list the scopes that we were using before. And if we now try to use the same command again, but instead of using the access token for the service account on the compute engine, we instead use this new token that we have obtained for the cloud function. So as before, we get the scopes and all the other information here as needed. But we also have a very interesting difference here. So if you look at this part here, we actually have the access scopes for cloud platform for this service account that is attached to the cloud function. Now, that is a largely more wide permission than what we had for the scopes for the compute engine service account. So again, even though we're using the same service account, the scopes are different for the compute engine versus for the cloud function. Now, if you would have gone one step further here and looked at the permissions that you have for this particular service account, now with this new token, you also would have seen that this has the permissions for the editor role in the GCP project. So in summary, what we have learned is that using the standard service account for the compute engine, you have some access scopes being set for what you are allowed to do. But that same service account can have different permissions when it's used for the cloud function, for example. Now, all in all, this is what we wanted you to carry out for Challenge 4. And using the compute engine access you have now pivoted to the permissions for the service account for the cloud function instead. And now you have more permissions than when you had in the beginning. And effectively, you have gotten access to the entire project using the editor role. Now, in summary, there are some caveats to take away from here. So typically, you would not have a cloud function set up in this way to basically give you an access token for this service account. But this challenge was made so you could understand how these different services can be used in combination and how the permissions can differ based on both the roles that are attached and the scopes themselves. So we hope you have enjoyed this workshop with us, and we have left you a fifth and bonus challenge for you to work with on your own. So thank you very much for listening, and we hope you enjoyed this.